Hello everyone, welcome back in the heart of our Paris Space Hub. We were expecting a demonstration from the F-35, but as it is not yet starting, we're going to start our Rising Star pitch session right now. A subject will be the technology for Nextspace, Eyes on Earth. 4 pitches from 4 startups, very promising startups. 8-minute pitch. And then we'll be done. And I'm really happy to call on stage the first pitcher. Name of the company is the Exploration Company. Victor Mayer is the lead Germany and Central Europe business. Please welcome him.
Hello, perfect. Thank you so much. So my name is Victor Meyer, and I'm leading the business in Germany and in the Central Europe part, so national focal point for Germany, UK, Switzerland, Austria. And what do we do at the Exploration Company? So the Exploration Company, we are building our own space capsules made in Europe. And I just brought here mainly pictures because I wanted to show you hardware and not just only renderings. But you can see on the bottom right-hand side what we're actually about to develop. So it's 2 products. One we call Nix Earth. So you can see that on the bottom left-hand side, a vehicle that is meant to resupply space station starting in 2028. And we're also working on a version that's going towards the moon and to provide logistics service on the lunar surface and back to Earth. And so who are we? What's this company about? Maybe you don't know us. So the Exploration Company, we're turning 4 years old in July. We have now 4 locations and are growing. Our headquarters is based in Munich in Germany. We have sites here in Bordeaux in France, in Turin in Italy, and also in Houston in Texas. We are right now, actually, as of today, 290 employees, so really right now in a scale-up mode. Within the past 6 months, we have grown by 110 people, so really growing a lot. And we have been able to secure 800 million euros of commercial contracts. This sounds like a big number, and where does it come from? So we are selling the service for 150 million euro on the market, and we're quite transparent about the pricing, which is one thing also that that our customers appreciate about us. So 25% of the missions or of the contracts are institutional business, so with the European Space Agency, the German Space Agency, and 75% of these contracts are commercial driven. So we have signed already missions with Axiom, we have signed 3 missions with Starlab and 1 mission with VAST, and so we have a backlog overall of 6 missions towards ISS and also the commercial space stations. And we are a privately invested company, privately funded company. Overall, we have secured 225 million euros of funding from private investors. And I would like to highlight some key achievements that we have passed in the past 3 years, actually. We have worked on the first demonstrator, which is called Mission Bikini. You can see that very nicely on that picture. We have launched it in 2024, so last year in July, on the maiden flight of Ariane 6. And it's a ballistic re-entry demonstrator. It's a very small capsule. You can see it, this brownish cork vehicle there. It's, the brown material is actually cork. So the cork you know from your wine bottles. And this is our heat shield. So it's a very cool product because it's ablative. It means it pushes the heat away. It's not burning. And it's a natural product. So it grows naturally. We can reuse it. We can actually, it's lightweight, so it's also cheaper. And so it's a very nice material to use actually for re-entry purposes. And it's a European technology, so it's not something that we have developed. This is actually something that has been already developed in the 80s and 90s in Europe. And the mission, unfortunately, wasn't really successful, unfortunately, because Ariane 6 upper stage had a malfunction. It wasn't able to bring us into the re-entry trajectory, so we are still on the upper stage, and we will do a natural re-entry in 2049. So unfortunately, we couldn't really see if the heat shield was performing at what we were expecting. So this was the overall mission profile. But in the end, what we did, we tested it in Stuttgart. There was a wind tunnel test, a plasma test, and we heated up the material to 3,000 degrees Celsius, which is like the temperature you would expect when you actually come back to Earth. Mission Possible is our second demonstration mission, and this is going to come very, very soon. So please stay tuned because we're going to launch this actually in the next days, I have to say. And this is going to be launched on SpaceX transporter mission. You can see a very recent picture from Vandenberg from the US. The vehicle is much bigger. So I told you Mission Bikini was like 0.5 meter diameter. Mission Possible is already 2.5 meter diameter. It weighs 1.6 tons. And we have 300 kilogram of customer payloads on board. So it's overall 26 customers from different areas. We have the classical space institutions that fly technology demonstrators, but also life science experiments. We have space companies that do technology demonstrators, and also non-space companies. We have the biggest cosmetics brand in Europe that is actually developing a new product, a new formulation in microgravity, making use of the crystal growth, and actually wanted to grow the polymers there for a shampoo, a hair shampoo product to increase the volume of your hair. So this is going to be an interesting experiment. We're going to see if this is going to succeed. And the mission profile will be, we're going to be launched with SpaceX out of California. We're going to be deployed in low Earth orbit, 400 kilometers height. And we're going to stay for 3 orbits. It's more or less 2.5 hours, 2 hours in orbit. And then we return, we do a controlled re-entry, meaning we use the propulsion system, our onboard computer, testing the flight software for the controlled re-entry of the vehicle to make sure that we're not pointing with the head upside down. Otherwise, the mission would fail. So we need to make sure that we actually come down with the heat shield, with the proper side. And then we're going to launch the parachute close before we land and do the splashdown in the Pacific Ocean in between Alaska and Hawaii. And so we will very soon we will know if this is going to be successful. And of course, fingers crossed, we're all looking forward to this. We also received the first hardware of our Nix Earth vehicle. So this will be the final product. You can see actually at our booth just over there, A27, we unveiled how actually the whole capsule is going to look like, also for human spaceflight. And the first mission we're going to fly in August 2028. So we're right now already receiving the hardware, and you can see a very nice picture here of the heat shield and the real dimension of it. It's 4 meter diameter. It will be able to fly 4 tons of payload up to the space station and 2.5 tons back down to Earth. So it's the first resupply mission that we're going to do on the International Space Station. As we speak here, our colleagues are in the US and with NASA, and we're going through the safety review phase 1 because we're going to be certified by NASA for this docking maneuver. And last but not least, LEO is not our final destination. We also want to go to the moon. And we built, therefore, our own propulsion system. You see a very nice picture there. You actually can see the real engine, which is fresh from the test there also in our booth, so don't miss it to see it there. And this engine is a 50 kilonewton thruster based on liquid oxygen, methane as a propellant. So it's a green propellant that we're using. And this allows us actually to create a high delta V to go towards the moon and to actually land on the lunar surface. And we are aiming to qualify the engine by end of next year. And we're going to fly the first mission after we have done the mission towards the ISS in 2029 and 2030. And here we're charging 200,000 euro per kilogram to actually bring payload on the lunar surface. Today you would pay around 750,000 to 1.5 million per kilogram. So you can see how drastically we can reduce the cost to actually bring stuff to the moon because we can increase the volume to go there. So overall we will fly there 2 tons of payload, which enables us to cut the costs. So please stay tuned. Please visit us at our booth just over here. And we look forward to our launch of Mission Possible. And thank you very much for listening. Thanks a lot.
Thank you. Thank you very much, Victor. Thank you so much. And yeah, your booth is right there. So yeah, good pitch. Awesome. Let's hear now Alexandre Mangeot. He's co-founder and CEO of Hyperspace. And there he is. The floor is yours.
Hi, everyone. Thank you. Sorry, what? So I'm Alexandre Mangeot, co-founder and CEO of Hyperspace. On your right, this is how it begins. So as a successful startup in the garden. And on the left, how it's going on right now. So Hyperspace has been founded in 2019 in France, Bordeaux, southwest of France, in order to develop hybrid rocket engines based aerospace vehicle, meaning that we are building our rockets and other systems around hybrid rocket engines. So if you look at the aerospace propulsion, it's quite a dilemma today because you have solid propulsion systems which are cost-effective, low performance. It's a fully matured propulsion technology and very adapted for defense applications. On the other side of the spectrum, you have liquid propulsion system, which is very expensive but high performance, fully matured as well, very often used for space transportation applications. And so this kind of propulsion technologies has been developed for quite a long time now. Mainly they are back to the Cold War era. So basically they are legacy and new space propulsion technologies. And today we are speaking about Nextspace propulsion technologies. And I tend to think that hybrid propulsion system will be the Nextspace propulsion systems because we are cost effective, high performance. We are being matured the propulsion technology, meaning that we are still have some developments to be done. And there are, hybrid rocket engines are very suited for space transportation and defense applications. So a hybrid rocket engine is like an hybridization between liquid propulsion system and solid propulsion system in a way that we have a liquid oxidizer into a tank that is injected into the combustion chamber that already contains the solid fuel. So this is why we call it hybrid, because we are between solid and liquid propulsion system. They are cost effective, we can throttle the propulsion system, and we are non-pyrotechnical. So that's the baseline of hybrid rocket engine. Unfortunately, in this configuration, hybrid system engine are not working very well at high scale. It's non-scalable. And what we have done at Hyperspace is that we have developed an innovation which is on the architecture side. We started from a blank slate for the architecture of the engine, which is presented on the diagram, and that makes the propulsion system scalable. So in 14 months last year, we scaled up the engine 100-fold. We started with an engine that can be fit onto the table to an engine that is 6 meters long, 1 meter in diameter, that can push 10 tons of thrust. So it's a 100-fold scale up. We did that with 20 people in 14 months. We did 3 ignitions of the propulsion system in 14 days. We did 3 test campaigns in the last 9 months, and we already reached 90% of the targeted propulsion performance, which is a very steep learning curve. We are currently at TRL 6 for most of the engine subsystem, and we are intending to reach the TRL 8 in the next year. And we are doing so with demonstration on a suborbital flight. Our suborbital rocket is called Baguette 1. It can carry up to 300 kilograms into suborbital trajectory, or also 200 kilograms at hypersonic speeds at lower altitude. And so this vehicle is supposed to fly next year. And if everything goes right, we will have a duplication of these propulsion systems to build our first orbital rocket, which has 7 engines at the first stage and 1 engine at the second stage. The rocket is called Obi-Wan. It can carry up to 250 kilograms of payload into low Earth orbit. And it's going to be the first 2-stage, 2-orbit vehicle without any turbopumps. And in the long term, we plan to replace these 7 engines at the first stage by a bigger engine. Since we have already demonstrated that we can scale up the propulsion systems, why not keep going? And so the vehicle you see on the right is an improvement of Obi-Wan. And once we have a bigger engine available, we will replicate the current architecture to provide a much capable launcher, probably around 5 tons into orbit. So this is how we are going to scale up our propulsion technologies and our launch capabilities into space. So basically, we are developing a new propulsion technology, if I summarize, that is really well aligned with the Nextspace specifications for space transportation. But we are also targeting defense applications, which make us a new defense startup. Thank you.
That was short. Thank you very much, Alexandre. Okay. Let's move on now to Nemesis, and I'm calling on stage Elise Corica. She's Marketing and Commercial Director of Nemesis. Are you here? Yes, she is.
Ok, ça marche. Merci beaucoup. Hi everybody, my name is Elise Corica and I'm the Chief Marketing Officer of Nemesis Technology. So some word about us. Nemesis Technology is an upstream manufacturer with a very strong and high expertise in shape memory alloy technology. We have developed and patented a very innovative material that allow us to push back design and performances limits of new actuators. With this material, we have developed a complete range of high performance and very smart HDRA and HDR aim for the new space and space application. They are used for deployment, release, and dismantlement. So to sum up, we are French, responsible, local, vertically integrated, and we are mastering all the process internally from A to Z, from the alloy fusion to the manufacturing, the assembly, and the testing. So how Nemesis can support you? By 3 ways. First way, with our standard range of space actuators. And the second way, we are also supporting our customer with very specific and custom-made mechanism. For example, we have been involved in the MMX mission by providing 2 remarkable actuators on the IDFX rover. We also developed innovative components, for example, smart hinge to very precise and control movement in aerospace application. We also made the sat latch shockless HDRM. It's a very smart mechanism able to ensure very smooth and progressive deployment. And the third way to support you is by offering engineering services such as simulation, characterization, test, dimensioning, modeling, sizing, and we can offer you an access to all our industrial facilities. Here is an overview of our current smart solution already available on the market, and the last one is under development and will be available until the end of the year. Triggy and Gripper, for example, are used to deploy antennas and solar panel. They are both already TRL9. SatLatch is a shockless mechanism for progressive and smooth deployment at any angle. Hector is the rotative actuator, ideal for a very deep space mission because he can work in very harsh conditions, and it had been selected to be on the MMX rover. Murphy is game-changing actuator. It operates passively by atmospheric reentry, and it can manage satellites' end-of-life debris. And the Harper is the last product under development. It's used to separate launcher from launcher stage and for separating satellites launching from a dispenser. All the complete range are fully resetable and easily by user, saving time and money for the customers. They are able to work in very extreme conditions. They are all heater-free. Some of them are shockless. The others are progressive and non-explosive. And if you want to learn more, I invite you to go to visit our website to see all the complete data sheets and some video presentation of how each actuator works. Some word about our flight heritage. We have a lot of flight heritage with the trigging. It's the first actuators developed by Nemesis in strong partnership with the CNES. Already over 255 actuators has been sold during the last 3 years. And to date, we have more than a dozen of flight heritage, including the maiden flight of Ariane 6 last summer. The gripper is already TRL 9. It has been flight qualified last November.
Take a short break for 10 minutes while the F-35 is flying. Sorry about that.